So chapter 27 is on lean manufacturing. You guys know what lean meat is? Yeah, it's not fatty meat, right? It's like meat without that much fat in it. So lean manufacturing is like manufacturing where you cut out all the fat, all the extra stuff that isn't good for you. My only problem with that is my favorite cut of steak is like the fattiest cut there is because the fat is delicious. So sometimes in meat and in business, when you cut the fat out, you might make it more efficient and more healthy, but less fun and less delicious. That happens in both places. All right. So let's talk about this. So almost everything we've learned up to this point espouses what you call traditional manufacturing principles. But many businesses have moved to lean principles in the last, I don't know, 40 years, we'll say, 40, 50 years. So I'll kind of, the mindset with traditional manufacturing is like, hey, we got to make sure we have enough inventory so that if we have an issue with our process, like our process breaks down or whatever, we'll still have enough inventory to give our customers what they need, right? Whereas in lean manufacturing, what we're saying is like, we should have less inventory. We got too much inventory. Inventory costs money to store. It costs money as it just sits there. And especially businesses that have inventory that's perishable, right? We don't want to over create that inventory or that is breakable. The more stuff we have sitting around, the more likelihood of some of it being ruined or spoiled or things that require, say, like refrigeration or things like that. Then it really costs money to store it because you're having to put electricity and everything else into keeping it cool. So so there's this shift, more inventory in the traditional mindset because it's safe, less inventory in the lean mindset because it's cheaper. Okay. Lead times, same idea. We had more lead time, and we'll talk about lead time a little bit more in a minute, but again, because it reduces uncertainty, whereas in lean manufacturing, we want less. We're just trying to cut all that extra out of there. Setup time, same idea. In traditional manufacturing, we don't care how much it costs to set up a process, because once we have that process set up, we're going to just crank out, you know, hundreds of thousands of units. And so even if setup's expensive and time consuming, it's just kind of part of the cost of doing business. Whereas in lean manufacturing, if we're going to be doing smaller batches and keeping smaller amounts of inventory, then we want to have less setup time, right? So that we don't have to do this big setup each time. A production layout. So under traditional manufacturing, we have process-oriented layout to our, this is actually to like our plant where we're producing stuff. Whereas in a lean manufacturing plant, we'll have a product-oriented layout. So I'll give you an example. The old car plants, there would be like this huge conveyor system, right? And if you even think of like FMI, where they dig out these massive amounts of ore, and then they put them on these conveyors, and these conveyors take them into crushers, and those crushers crush it all up into a powder. And then that powder is dissolved in an acid. And then there's this electrowinning process where cathodes and anodes are put into this dissolved mixture, and it pulls the copper ions out of it, right? I mean, there's this whole process that's very much based on process. We're under the new product-oriented system, which they haven't really moved to at FMI, but in like auto plants, instead of like, we're going to have this auto chassis moving down a line, and then this person's going to put on tires, and this person's going to drop in an engine, and this person's going to do that. Instead, what they do is bring a product to one station, and all the stuff is done to it right there, and then it's moved on to another station. And so one is product-oriented versus process-oriented. In traditional manufacturing, the employee was thought of as pretty much a cog who did a function, wasn't supposed to think. Think of like Henry Ford's auto plants, where it was just like you're putting a widget into a sprocket over and over a million times a day. Under lean manufacturing, what we're trying to do is we want the team member to think about their process and think, is there a better way to do this? We want to cross train them so they know how to do several processes, so they start to see the interrelation between processes, so that they're part of the process improvement. I think earlier this year we talked about, even like what's going on in the battlefield in Ukraine, and how Russians have this sort of traditional mindset, which is like the command and control all comes from the general, and the Ukrainians, who have been trained by the Americans, have this much more team-oriented approach, which is like the people on the ground can make decisions and even change the mission if needed. Maybe your mission was to take out a certain tank, and when you realize that that tank is not the best target anymore, but the tank at the lead of the column is, because they change things, you can adjust on the fly. Same idea, okay? Under lean manufacturing, we're allowing employees the power to sort of make adjustments on the fly, and it's certainly to inform improvements in the process, instead of like your job's to put together those widgets and don't talk, right? What's interesting is this idea, team-oriented thinking, has been around forever. It's not new, but it was traditionally kind of reserved for areas of, academia, where you had these professional level employees. And what we're realizing is people aren't stupid, right? Like just because someone works on a production line doesn't mean they don't have value. In fact, the person who works on a production line, who does the process over and over and over, may have insights that the manager who just thinks about it in theory doesn't have. Okay, so that's the idea. All right. Production scheduling. Old manufacturing was called push manufacturing, where what we would do is we would say, we have all of these raw materials, let's push them through and make as much inventory as we can. Whereas pull manufacturing says, let's sort of wait on our orders, and we'll set up a system that works so well that as soon as we get an order, we can just create a batch and produce that order. And that way we don't have a bunch of stuff sitting around. Again, I actually did a study for this on the local tortilla factory when I was doing some of my doctorate work, and their processes, because they had a traditional process where they would just buy this whole storeroom full of flour and masa and whatever raw materials, lard they needed to make tortillas. And they had a lot of spoilage, and they had problems with rodents. It's hard when you're keeping a storeroom full of food to keep it insect and rodent free. They sniff that stuff out. And so they wanted to shift to a different process. Instead of just making as many tortillas as they could and then hoping they could sell them all, they wanted to be able to say, let's take orders and tell people they have to have orders in 72 hours in advance. And then when we have that order, we'll pull. We'll say, for this many orders, we need this much stuff. So they go to their supplier drops it, never has to be stored, drops it right on the production floor. They mix the batch, they mix, form, shape, cook, package right on the truck. And then so before, they were storing raw materials when they came in and storing finished goods while they were waiting to be sold. When they switched to a more lean system, they didn't have to store raw materials. They could have them delivered just in time, and they didn't have to store finished goods because they already had an order for them and they were just shipping them out. And the customer was happy; they were getting fresher product, and so it saved them money and made customers happier. Yeah.
You ever seen a company that switched the other way?
I think that there are companies at times who they really do just have to be in a mode of like, we need to produce. Especially if there's a market shortage. Okay, so when there's a market shortage, that usually means your price is going up too, because it's supply and demand. And so when there's a supply side issue, or when there's a demand issue where you have more demand than you can support, then you kind of go to this process of like, let's just crank out as much of this product as we can. That's harder in the modern world where there's so much competition, even from like overseas and stuff like that, right? You have a broader group of people all competing for stuff. All right, so quality. Under traditional, we figure defects are part of the process. Under lean manufacturing, we want to get to almost zero defects. Like, that's our goal, okay? Instead of just saying, oh, well, that's just part of it, because we produce so many billions of these things, we're going to have some defective ones. We're saying, no, we're using these in small batches and we have more control over the process. Finally, suppliers and customers. In traditional, suppliers and customers were kind of like these independent entities that we got our stuff from them, but that's as deep as our relationship went, and we sold our stuff to them, but that's as deep as our relationship went. And now we recognize under a lean manufacturing system that suppliers and customers were almost like this says a supply chain manager. I say almost like a team. If you see yourself as so you start to educate your customer. Here's how our workflow works. So if you'll order on this day, we'll be able to flow this through to you. And if the customer says, I really need it on this day, you might even adjust your process. Like that wasn't the old way of thinking. Okay, the old way of thinking was like, no, we produce and you buy. Now it's like, well, why don't we all work together? And if we can find a solution that makes everybody, saves us all money, why wouldn't we do that? All right, that was a lot of talking. I'm not going to go into any more depth on all these except for lead time, which was the second one. That's as much depth because there were slides for all of them. But on lead time, we need to consider a couple things, okay? So lead time means the time interval between when a product enters production and when it finishes production. So we call that lead time, like when someone comes to you and says, hey, can you make me this? And you say, well, it's going to take me a month to get this to you because of my lead time issues, okay? So it just really measures how long it takes to manufacture a product. So typically we break lead time down into two categories. One we call value-added lead time, which means time spent converting the raw materials into a finished unit of product. And the rest is non-value-added lead time. And this is usually time that's wasted either on setups. So we have products in the process, but then we have to set up the new equipment to work for it, or on wait time, right? So like, we have a bunch of products sitting there waiting to be processed. You can never fully get rid of wait time, right? If your machine can only do one at a time, then all the others waiting to be made are waiting to be made, and so you can't fully get rid of it. So here's our components of lead times. So you have raw materials. So here it's just sitting there, right? We call that non-value added time. Here it's being moved from one place to another. That's non-value added. Here we're drilling it out. So that's value added. That's when we're actually converting the raw material into a finished good. Then it's waiting. Then it's being moved. Then it's being packed. We consider that value added because it's part of the process of what's needed to get it to the customer. And then finally the end of production. So most non-value added lead time is in wait time and movement time. And so that's why this shift, remember I said we shifted from a process-oriented factory where we move the things around to the different areas to product-oriented. We're just going to do all the work on it in one spot, okay? It's actually easier to move a person from this location to that location than it is to move, say, like a car chassis, right? And so it might make more sense that the car stays and the people who have specialized jobs move from station to station to station. And something I mentioned this earlier, like when I was explaining how the process flow of things, I said, a lot of times they'll use barcode scanners and stuff, so they're measuring each product. Now they don't even use barcode scanners. They use those little, what are they called? RFID tags, little radio tags, because now we don't even have to scan them. Just as it comes through this area, the reader picks it up and says, oh, this is product number 61872 or batch number, whatever. And so it's just, the intent is to like speed this up, less wait time, less time doing non-value added things. So one thing you'll need to know, this is why I gave a little more detail on this, is something called a value added ratio, okay, which is just our value added lead time divided by our total lead time. Or in other words, what percentage of our lead time is value add out of the whole amount, okay? And imagine just the higher that is, the more efficient your process is, the less sitting around, the less waiting for stuff. So here's an example of a product being made. So they move the raw materials to the machining department, and they machine it, move it to assembly, then they do the assembly, move it to packing, wait time for packing, finally the packing. So you have 125 minutes of total lead time, but only what, 35, 45, 55, 65 of those are value added time. So I guess, yeah, 65 out of the 125. So that gives us a value added ratio of 52%. So under lean manufacturing, what we'd be asking is like, how do we improve this? Right? If it really takes 10 minutes to move it, is it just a matter of rearranging our plant so it takes less time to move stuff? Maybe. Can we do the machining and assembly in the same place? Maybe. Not always, right? Like, again, what we're trying to do, and when we think in these terms, is we're trying to just improve our processes. Okay. Because sometimes you'd be like, I have a solution. We just do it in the same place. And then some other managers will say, well, here's 3 reasons why that's not a good idea, or whatever. You know, who knows what it is? Maybe machining makes a lot of sparks and our assembled product is flammable. So we don't want to do that, you know, in the same place. Who knows? I mean, but these are modern managers are trained to think this way. How do we reduce lead time? Okay. All right. So I left these little checkup corners in because they're interesting. I don't usually leave them in because I'm just trying to trim stuff out. But so lean concepts with their appropriate description. So which one describes batch? The time interval between when a product enters production and it's completed? Nope, that's not a batch. That's lead time, right? Products are manufactured only as they are needed? Nope. That's pull manufacturing, right? E, the amount of production in units of product that is produced after a setup. Okay, so each time I didn't define that well, so we had to work through it. So a batch is the amount of production units per setup. Lead time was the time interval from when a product enters production to when it's completed. A product-oriented layout is B, right? A manufacturing process, or is it? Yeah, that reduces moving materials and products between processes, work in process inventory, lead time, and production costs. Pull manufacturing, products are manufactured as they're needed by the customer, and setup time is the effort spent preparing an operation or process for production. All right. All right, so here's our little lead time analysis. Helping Hands Company manufactures designer gloves. Helping Hands. You know what I think they should do? They should make work gloves that look like dainty and pretty, because there's more, you know, people coming into the workforce who care about how they look. All right. I don't want this big rugged leather glove. I want something that looks like lace but protects my hands like leather. All right. Yeah, it's okay. It's a Stevie Nicks song. All right. Gloves are manufactured in 50 glove batch sizes and cut and assembled by the company's workforce. The cutting time is 4 minutes per glove. The assembly time is 6 minutes per glove. It takes 12 minutes to move a batch of gloves from cutting to assembly. So they want us to compute the value added lead time, the non-value added lead time, and the total lead time. This is a little confusing. That's why I wanted to show this example. And then compute the value added ratio, okay? So to do our value added lead time, it's the amount of cutting time and the amount of assembly time, 10 minutes. Now you would think that you then multiply that by the number of gloves, but that's not what they say, okay? So our non-value added lead time is the total within the batch. So here we have 10 minutes times 49. So our batch size is 50 gloves. So if we take our batch size minus 1, that gives us 49. And so because the first one starts immediately. Okay, so when we start a batch, the first process starts immediately. So to find our in batch time, how long it takes for these gloves to be in their batch being worked, we take our our number of units in the batch minus 1, multiply that by the total value added lead time. So that's going to give us our total within batch time. We have our move time per batch. So our total non-value added lead time is 502 minutes. And then if we take our value added lead time, add that to our non-value added lead time, our total lead time is 512 minutes. So here's the logic. This is a little confusing. Is to me, it's like, well, each time you're cutting a glove, that should be value added lead time. But this is saying only the first one is value added and the remaining are non-value added. Why? Because they're all waiting. Actually, it's the last one, if we're being honest, that's value added. And all the ones that are sitting there waiting in the meantime are wasted time. And so how could you fix that process? Well, you could get an piece of equipment that stamps out 50 gloves at a time, right? That would be a way to completely eliminate that wait time, as that stack of 49 gloves, which is just the raw leather, is sitting there waiting to be cut. Okay. Anyway, so our value added ratio then is the 10 minutes divided by the total of 512 minutes, or 2%. They need to look at their process, right? Some manufacturers, do you know where a lot of gloves are manufactured? We used to think it was license plates. They're manufactured in prisons. There was always that like thing. A lot of gloves use prison workforce labor. So sometimes you actually are okay with all of this wait time. You'd rather, if you can pay somebody, $1 an hour, you'd go ahead and not pay for that big fancy piece of equipment that stamps out all the gloves and pay that lower labor rate. But again, there's a lot of things going on that are part of our decision-making process. All right, so with lean manufacturing comes lean accounting. Our federal prison used to make gloves out here. I don't know if it still does. I toured it years and years ago, and they had a glove making little plant in there. All right, so this is a little different from what we've been doing. Okay, lean accounting emphasizes fewer transactions and the combining of accounts. Okay, so let's talk about that. When we combine accounts, we're saying all in-process work is combined into a single RIP inventory account, raw and in-process inventory. So right now we're used to 3 in-process, or raw materials, work in process, and finished goods. They just combine raw materials and in-process all in one. The idea, if you think about the philosophy of not storing your raw materials and then converting and then storing finished goods, the idea is just like, since we're buying raw materials just in time to work on it, we're just going to say raw and in process are all one account. Yeah. Right.
So you're writing off raw materials.
Yeah, I wouldn't say you're writing it off. I'd say it's being included into the cost of your manufacturing.
Yeah, it's a part of it.
Directly. If it goes to waste. So direct labor is also combined with other costs to form a new account titled conversion costs. Okay. Also, we focus on non-financial performance measures, sometimes as much as we do financial ones. And a lot of times we direct trace our overhead. So indirect labor is directly assigned to product sales, and we'll talk about that in a minute. So we don't worry about overhead as much. So typically, in the ones we've learned about, traditional process does things by department, sometimes by batches. We do that because it helps us control costs by department and understand how much each department costs, but it also requires a bunch of additional transactions to worry about moving it from department to department to department. So in lean manufacturing, we're less worried about cost control from a department standpoint, because we're going to do this lower inventories, and that's going to help make those problems more obvious really quick, right? If you're doing low inventory and you're just pulling it through the system, you're going to start to see where the hangups are along the way. When you're like, no, we've got to get this batch done. Oh, well, this is the process where it gets hung up. Okay. So in lean accounting, we use something called backflush accounting. We eliminate the accumulation and transfer of product costs by departments. Instead, we pull everything directly to finished goods. So we're losing some of the finite detail of where the issues are, but we're gaining the efficiency of the process of not having to record every little move of stuff. So materials are received directly by the product cell and enter immediately into production. No central materials inventory location. Again, we put it right into that RIP, raw and in process. It debits all materials and conversion costs to an account titled raw and in process inventory. Let's see. Again, we don't try to separate usually direct labor and just other labor. Instead, we assume that the people working in the production floor can do the labor. So there's not like, well, this part of their time was spent sweeping the floor. We're just saying it's all part of the cost. Okay. All right. So here's an example. Anderson Metal Fabricators, a manufacturer of metal covers for electronic test equipment, has budgeted conversion costs of $2.4 million and 1,920 planned hours production. So the cell, and cell is a confusing word. It just means like a batch of product, okay? So the conversion cost rates determined as this: our budgeted conversion costs divided by our planned hours of production. It's going to cost us $1,250 per hour to convert the raw and in processed into finished goods. This little thing, it's similar to predetermined factory overhead rate, except it includes all the conversion costs, not just overhead. Okay. If you remember, the conversion costs before were the materials, the direct labor, and then the overhead. So it requires 0.02 hours of manufacturing time per unit. So if we know it's $1,250 an hour, then our conversion costs are 0.02 times 1,250 or $25 per unit. So we know that it costs us, again, this is probably a little quicker and a little dirtier. And what I mean by dirtier is we don't know as much detail. It might be harder to track it down. And in essence, the reason why it's okay is because we're usually producing small batches of things, smaller batches based on customer need. And so we can start to see those issues just by watching the process go through, instead of having to come up with these big mathematical ways of figuring out which department is more expensive, okay? So here's the transactions we use in lean accounting. So when we purchase materials, we just debit them right to raw and in process inventory, whereas the old way would have been raw materials inventory, or yeah. When we apply conversion cost, we just increase the raw and in process inventory and credit conversion costs. When we complete it, we debit finished goods and credit raw and in process inventory. And then when we get paid, it looks the same. Accounts receivable goes up, sales, that's at the retail price, and then cost of goods sold and finished goods at our cost. So that hasn't really changed. Really, the only thing that's changed, if you think about it, is no longer worrying about overhead, which is kind of the biggest pain in the butt about the old way. We're just going to do it right. We're going to put all those costs into conversion costs, and that we only have two inventory accounts: raw and in process and finished goods, rather than raw materials, work in process, and finished goods. That's only the only big changes. Okay. All right. So here's a problem for us to work through. The budgeted conversion costs for a lean cell are $142,500 for 19,000 or 1,900 production hours. Each unit produced by the cell requires 10 minutes of cell process time. During the month, 1,050 units are manufactured in the cell. The estimated materials cost is $46 per unit. So it wants us to journalize the materials to purchase and produce 1,100 units. the conversion costs applied for 1,050 units, and then 1,030 units placed into finished goods, 3 journal entries. All right, so for the first one, we have 1,100 units times $46 material cost per unit. So the purchase of that materials was 50,600. So we debit the raw and in-process inventory, 50,600. We credit accounts payable. Easy. I mean, this isn't a major change, okay? Other than it's just a single account. B, so we have 142,500 budgeted conversion costs, 1,900 planned hours of production, which gives us $75 cell conversion cost per hour. We multiplied it by 0.1667, which was 10 minutes out of 60 minutes, because it takes 10 minutes to make each unit. And that gives us the conversion cost per unit. Then we multiply that by 1,050 units produced, gives us our conversion cost. Really what we need to know though is that we debit the raw and in-process material process inventory for any costs added, conversion costs added, and we credit conversion costs. Finally, when we move them to finished goods inventory, we have $46 in material cost per unit plus $12.50 in conversion cost per unit gives us $58.50 conversion and materials per unit times 1,030 units completed. 60,255 goes into finished goods inventory. So we debit finished goods inventory, credit raw and process inventory. That's the process. Okay. All right. I mentioned earlier that with lean manufacturing, we focus sometimes just as much on non-financial performance measures as we do on financial ones. Maybe you've already heard the term KPI. Have you ever heard of that term? KPI. So even at the college, we have KPIs. That means key performance indicators. Okay, and a lot of times they don't necessarily mean something financial. Like in my area, one of my key performance indicators is my DFW rate, which means the number of students who earn D's, F's, or W's, withdrawals, in a course. And so we want to make sure that rate isn't crazy high, right? And so we get a DFW rate across the whole college, and then we'll compare a division or a department's DFW rate across the college DFW rate. And so we have this target, like we recognize some students will fail classes. Sometimes no matter what we do, right? We'll recognize some students have to withdraw. They have something come up in their life and they have to just, but that's a non-financial measure. And if we get too far above or below, right? Because if like 100% of your students are passing, sometimes that means you're not being rigorous enough. If 70% of your students are only 70% are passing and 30% are failing or withdrawing, maybe that means you've got some other issues. And so a lot of times what KPIs do is they don't necessarily tell you what the problem is. They give you an indication that there might be a problem that you can then dig deeper into, right? And say, well, what does that mean? So it's, for us, we don't want it to be too high or too low, because if it's too high, well, if it's really high and we say, let's look at that deeper, and then we find, well, there's some really great teaching and that really nurtures students through or something, then what we try to do is copy that and say, well, how else can we improve on that? But other times it's because pretty much if you just show up, we give you an A or something, well, that isn't necessarily healthy. So non-financial measures. Okay, here's the most common ones, things we already talked about. Lead time. How long does it take us to actually produce the product? Our value-added ratio, setup time, etc. You can read those. I won't read them all to you. But those are common key performance indicators in manufacturing businesses. As you can imagine, in non-manufacturing businesses, you could still have KPIs. Even in my church responsibilities, okay, I have KPIs, key performance indicators, things I'm looking for, the percentage of people in my church unit who are attending church weekly. If that gets way off, we have to ask ourselves why, right? So, I mean, you could think of these in almost any context they exist. Yeah, non-financial KPIs are usually a little easier to figure out just because you don't have to have all the accounting back work. A lot of times, they lag a little bit in financial things. Let's see. I mentioned this before, that in lean manufacturing, there's direct tracing of overhead. So we just assign a lot of the indirect tasks directly to a product cell. And then those get just wrapped up into our conversion costs instead of having a separate overhead cost. All right, activity analysis. So these are where we are trying to figure out, like I said, when we start to see these KPIs off, we want to do analysis to figure out what's going on with them. And so we work with what's called quality. Have you ever heard of total quality management, TQM, or quality assurance? Okay, those are ways we measure quality. We want to focus on value-added activities and then improve our processes. Okay. So to have quality, we incur costs of quality, and we break those down into 4 areas. This is actually going to be one of the harder parts of this chapter, okay, because it's taking you back to like accounting 1, where you were like, the math isn't hard, but like putting things into the right categories is confusing at first. You remember how hard like assets versus liabilities and all that was in that first few weeks? You're like, my brain is not getting this. And then after a while, it was like, how was that so hard? What was that, Emily? You're like, still hard. So we're going to break down our quality costs into prevention costs, which are the costs of preventing defects before they happen. Okay. So anything like hiring or doing good engineering so that our product design is good upfront, right? Controlling vendor quality, meaning make sure we're getting good raw materials. All of those things are considered prevention costs, things that prevent errors from happening. Appraisal costs are the costs of activities that detect potential errors. Inspections, things like that. Internal failure costs are the costs associated with defects discovered before we deliver a product to a customer. So as part of our inspection, we find issues, right? So any problem, any costs of fixing that, where we scrap or have to do rework. Anybody ever work construction? How much, what percentage of a total cost on, say, like a remodel is rework, where your guys did the work and then the boss comes in or the owner of the house comes in and says, that's not okay, and you have to tear it all out. You ever had to do that? It's costly. Also, another field that has a lot of rework is what's it called, like landscape and stuff like that. People are never happy with how you did their yard, right? At least my mom was never happy with how I did the yard. And then finally, external failure costs. So really internal would be when your manager comes in and inspects your work and says, no, you're gonna have to redo that. And external would be when the customer comes in and says, that's not acceptable, right? And that's even more costly in some ways because you made the customer unhappy. Whereas if you find it before, that's better. All right. So again, our costs of controlling quality, prevention costs and appraisal costs, and then our costs of failing to control quality, internal failure, meaning we recognized it, or external failure, meaning the customer, or heaven forbid, some sort of outside inspector, like a government inspector or something like that, right? Where you're going to get fines and other things for not getting it done right. Let's see, I think I talked about all that, so we can just sort of skip through that. Let's see, I'm trying to think of if we want to go deeply into this. I think what we find is this. So if you take a look at this chart, you'll see that it's a much cheaper way to get as many good units as possible by engaging in prevention and appraisal than in having failures. Okay, that's what this chart's really telling us, right? We're going to always have some failure, but the more prevention we spend on, the how quickly it's going to drop those failure costs. Okay, the problem is with some businesses is they don't really understand how to do prevention, And so what I mean by that is they're spending all this time and energy to try to like keep problems from happening, but they haven't really done the work to figure out what are the types of problems we expect to see, right? And that's where good engineering and good, whether it's manufacturing a product, or in the case of the college, for us, our engineering would be to kind of look ahead and say, what problems would we expect to have happen here? And how can we forestall them or completely eliminate them? All right, so activity analysis of quality quantifies the costs in quality in dollar terms. So here's an example of a business, the Gifford Company, and they've got all these different quality control activities and then activity costs. And so imagine a problem where it doesn't give you this third column, and your job is to identify which of these are prevention, which of these are internal failure, which of these are appraisal, which of these are external failure. And then you produce, this has a Pareto chart. And then you produce a little report that just shows, here were the costs of prevention, here were the costs of appraisal, here were the costs of internal failure, it just breaks them down, okay? A common tool they use is what's called a Pareto chart. Any of you who've taken business stats, we looked at Pareto charts. And all a Pareto chart does is it really shows sort of like in reverse order, highest to lowest, the categories. This is super valuable, and sometimes you'll even see that it'll have like a line graph that goes this way that shows you the cumulative. So you can see, oh, after these two, that was like 80% of my costs were from rework and warranty work. Okay, this is valuable to me as a decision maker because I can very quickly see where my costs are originating, and then I can start to take steps to improve that situation. So there's the quality report, right? So it breaks down prevention, appraisal, internal failure, external failure. So you'll see right now, this business has some serious internal failure issues. So they should probably take a hard look at what those internal failures are, and even their external failures, they're massive, and then revamp their prevention process and their inspection process. And what they would probably do is spend a lot less money and have fewer defects overall, right? That is not where we'd like to see that at. So here's an example one, quality control activity analysis. So we're spending $50,000 verifying the accuracy of our form. We're spending $100,000 responding to customer complaints. We're spending $75,000 correcting errors in the forms, and then spend $25,000 redesigning forms to reduce errors. So our quality report would look a little bit like this. Prevention, $25,000. That's the cost of fixing the forms, so we're not going to have the problem in the future, right? Appraisal was $50,000. That's verifying our accuracy. That's like an inspection, looking at the form, making sure we're doing it right. Right now, our cost of internal failure, $75,000, and our external failure, this is caring for mad customers mostly, is $100,000. The hope is by doing this more, we're going to reduce the things down the line. All right. Another way that we try to sometimes do activity analysis is by separating things into whether they're value added or not value added. Okay. And so in this sense, and really in the manufacturing sense as well, value added activity is one that is part of meeting the customer's needs. Okay. And a non-value added activity is all the other stuff, dealing with mistakes, trying to make a mad customer happy. Okay. So again, we would just look at a list of things and we would just define what are value added and what are not value added. So non-value added are things like disposing of rejected materials, processing the return materials, disposing of scrap, rework, right? Fixing it because it was wrong, and warranty work. Those would be our non-value added, and our value added be things like engineering. So up front, figuring out how do we do it right. inspections where we're checking it to make sure it's right before it goes out to the customer, preventative maintenance, assessing the quality of the materials we're getting. So then what we could do is just divide it up that way. We have value added. So in this case, only 26% of the money they're spending is value added. The remaining 74% is non-value added. Again, that's not where we'd like to see that at, okay? And so these are, if you think about it, these are all about ways of identifying how well your process is working and improving it, right? So process activity analysis. Remember, a process is a series of activities that converts an input to an output. Ooh, that's starting to sound like econ terminology, doesn't it? Yuck. So those are processes. Same idea. Here at the college right now, we're getting a new computer system that's going to manage all of our processes. And so we're starting a process of mapping all of our processes, right? So saying, okay, what is the process by which we decide what classes we're going to offer and what times they'll be offered, and where it goes from an idea to like being what's there for students. There's a process that goes through. If we have a new class that someone wants to start teaching, what's the process by which that gets approved, right? All of those, we're having to map those out and say, well, how have we, because we do them, but nobody's ever like drawn a map to say this is how it happens. And it's a ton of work, okay? And so same idea. This is just an example of their sales order fulfillment process, that a customer gets a credit check, they enter the order is picked up from the warehouse, the order is shipped and is received by the customer or whatever. Okay, that's the idea of a really simplified process map. Yeah, that's kind of what I just said. So they start to figure out, though, in that process, these 4 things are happening. You can break down the costs of each of those. Find out it's costing us $80,000 to fulfill customer orders. If there was 10,000 orders, it would cost us $8 per order, okay? A lot of times people are spending tons of money on processes and don't even realize really if there's a better way or not to do it. Again, I won't read that to you. Same idea as the other stuff. We use these to try to improve the process. All right. So again, picture a problem in your homework or something like that. That's kind of telling you, okay, we're thinking of doing this improvement. So the improvement's gonna reduce the cost of customer credit checks. It's not going to change the order entered in the computer system. It's going to reduce the pickup cost, shipment. It's not going to change that. So is it a good thing for us to do? And you look at it and say, okay, it looks like it comes out cheaper and saves money. So it is. That's the idea. All right. So that's this chapter. Like I said, it was a lot of conceptual stuff and not as much mathematical stuff, which maybe will be nice, unless there's a problem where you're like, why? Just let me do math and I'll figure it out. Anyway, so we have this chapter and then one more chapter after it. So we're getting to the end of new material. That's exciting. Coming up soon, and we'll talk a little bit about what to expect for the final exam. I mean, we're still a few weeks out, okay, but we're getting there. So that's exciting. Anyway, have a great day. And well, that's all I got. Have a great day.